This probably has a few more zeros than we're used to, and we have some exponents. But when we have the factored form, to find the zeros, all we have to do is set each piece equal to 0, right? So if I set 3x equal to 0, you get x equals 0. That was just to the first, so my multiplicity is 1. I don't have to write anything. The 4x minus 5. If I set that equal to 0, we get 5/4. That whole parenthesis was to the third, so what's my multiplicity? 3. And we just write that as an M3, M for multiplicity. Okay, the last one. If I set x squared plus 3 equal to 0. Subtract over your 3. To get rid of a square, we add a square root. When you add a square root, you also do a plus and minus. What would you do for the square root of negative 3? We have positive and negative, I radical 3. What would be the multiplicity on that one? 5, because it was to the 5th power. So those are my zeros. Alright, so if something is factored, finding the zeros is pretty simple. All you have to do is set each thing equal to 0. We've been working problems where we had to first factor them. Your homework last night, that last section, I gave you the first 0 and you had to do synthetic and get down to a point where you could either factor or do the quadratic formula. So we're going to keep looking at these types of polynomials today, but today we're going to start graphing. First though, you have a homework assignment for me, so let's get out that and we're going to grade that assignment. So we have been taking polynomials and factoring, finding the zeros. Today, we are going to start graphing these polynomials, and we're going to spend the rest of the week on this. So there are certain steps that I'm going to ask you to do in order to factor these polynomials, and I would appreciate if you would jot these down. On a test or quiz, I'm not just going to have a question that's going to say graph polynomial. I'm going to break it into these steps. I'm going to say step 1, tell me the end behavior of this polynomial. Step 2, tell me the zeros. Step 3, and so you don't necessarily have to memorize these steps. I will break it down for you exactly what I want when I give you these problems. So in behavior, we've been doing. We know how to find that. It's based off your degree. The zeros, that's what we did on that last section of homework last night. You know, if it's factored, you just set each parenthesis equal to 0. Step 3, the through or bounce, we have touched on before. Remember, it's based off the multiplicity. If your multiplicity is even, what did we say happened on the graph? Right, even, it bounces, and if it's an odd multiplicity, it goes through. Okay, so we've talked about that. A y-intercept, we haven't done specifically with these problems, but you've done it plenty of times in the past. A y-intercept is, when we find intercepts, we always set the opposite variable to 0. So to find your y-intercept, that's when your x equals 0. You plug in a 0 for all of your x's, what do you get out? It's where your graph hits the y-axis. And then we will take all this information and draw the graph. Okay. So, first problem, we are drawing these things by hand. Now you obviously have a graphing calculator so you can check yourself, but on these problems I'm asking you to find certain things. Everything that I ask you to find I expect to see on your graph somewhere. So here is our first problem. I want to sketch this graph. P of x equals 2x minus 1 times x plus 1 times x plus 3. And so we're going to use those steps. that I just outlined. Step 1 is the end behavior. I usually just say EB, end behavior. If you multiply this out, you would have x to what power? The third. So it doesn't have a negative in front. Remember, anytime it's odd, it looks like a chair. Negative splits that. It doesn't have a chair, so what's my end behavior? Or it doesn't have a negative, so what's my end behavior? If you absolutely got confused on your end behavior, how could you figure it out? Look at a graph. Okay. Step 2. I told you I wanted the zeros. Now I've really already done the hard work for you. I already factored this thing. So to find your zeros, you just set each of these parentheses equal to 0. So we need to know what makes 2x minus 1 equal 0. And that would be 1/2. What makes x plus 1 equal 0? -1. And what makes x plus 3 equal 0? -3. So I have 3 zeros, which I expect because I said degree was 3. So we should have 3 zeros. Okay, third step. For each of these zeros, I'm going to tell if the graph will go through them or bounce. And it's based off the multiplicity. Okay, even multiplicity bounces. I'm not talking about if the number is even, I'm talking about if the multiplicity is. What's the multiplicity of all of these? Just a 1. 1 is odd, so what will happen at all of these? The graph will go through. So I'm just going to write through all. Okay, fourth step is the y-intercept. To find that, you plug in a 0 for all of your x's. So 2 times 0 minus 1 is -1. 0 plus 1 is 1. 0 plus 3 is 3. And we get -3 for the y-intercept. Bless you. Step 5 is a graph. On my graph, I'm using this information to get it. I know my end behavior is down up, so that means my graph is going to start down here and it will end up here somewhere. My zeros. Zeros are the same thing as your x-intercepts. So I hit my x-axis at a positive 1/2, -1, and -3. My y-intercept is -3, so we hit the y-axis at -3. So I put all of those points on, all my intercepts. Now we're doing a rough sketch. This is not real precise because I only have 4 exact points on my graph. But we're drawing in the polynomial. Remember, polynomials, there's no breaks in the graph. It's a nice smooth curve, so I don't want to see like a V or anything like that. It is curved. We know since this end is going down, it has to start down here. You have to hit your x-intercepts. What did we say? Are we going through or bouncing? Going through all of these. So I'm going to go through it. I have to come back to hit this one. So I'm going to come back and hit this one. Go through. So I'm going to come down. Have to cross my y-axis right here. And it said go through, so that would point up, and that's the direction we said our graph would end. Now, is this graph perfect? No. It may be the case that the real graph looks, maybe it's something like this. I don't know. But we have a rough idea. How can you check yourself? Graph it. Plug this into your graphing calculator real quick. See how close they are. So you go to your y equals and put in that original polynomial. Are we close? Use that to double check yourself. But I do expect when I'm grading this, I'm going to look, did you only touch the x-axis at your x-intercepts? Did you cross your y-axis at your y-intercept? Those are the only places. Okay. Any questions on that one? Let's do another one. This one is a little bit different because I did not factor it for you first. Let's see what we can figure out though. Step one, our end behavior is based off the degree. What is the degree of this? 4. It's our highest power. So if it's even, it looks like a parabola. So our end behavior would be okay. Step 2, the zeros. To do this, I need to have this in factored form. On our homework, we were factoring a lot of them, but I gave you the first 0, and I didn't even give you that this time. Do we know any techniques for factoring something like this with 4 terms? In fact, the beginning of the year when we did factoring? Grouping. Should we try that? So grouping says you put the first 2 in parentheses and the second 2. What could you pull out of the first 2? That leaves us with an x minus 2. What about the second 2? We got an 8, and that leaves us with an x minus 2. Okay, what can I pull out of this? We have 2 terms. What do they both have? And if I take out the x minus 2 from each, I'm left with x cubed plus 8. Okay. Technically, x cubed plus 8 can factor. It's a sum of cubes. When we did those, I just gave you a formula to factor it. But I'm just going to leave it like this because I think we can find our zeros from here, can't we? If you set the first parenthesis equal to 0, if x minus 2 equals 0, you get x equals 2. If x cubed plus 8 equals 0, what would you do? How do you get rid of a cube? Cube root. Do you have to do a plus and minus if you do a cube root? No, only for an even root. And what's the cube root of negative 8? Negative 2. Because it was cubed, what would our multiplicity be? 3. Okay. So that's our zeros and multiplicities. Now we tell if we bounce or go through. At 2, the multiplicity is 1. 1 is odd, so the graph goes 3. This one, negative 2. The multiplicity is 3. 3 is odd, so the graph goes through. So you can say through both. You can draw arrows and telling me however you need to make it clear that we're just going to hit and go through on both of those.
How did the negative under the square root, did it make it imaginary?
If it's an even radical, it can, but odds can be negative because if you take a negative 2 times a negative 2 times a negative 2, you do get negative 8 out. Okay, what's step 4? Y-intercept. If you plug in 0 for all of your x's, you can do it in the factored form, you can do the original. If I put it in the original, I get 0, minus 0, plus 0, minus 16. So my y-intercept is just, okay, draw our graph. My end behavior is up, up, so both ends should be pointing up. My zeros, I'm hitting my x-axis at -2 and +2. Y-axis at -16, I'm not going to require you to be extremely precise here. You can count by 4s. If you have a really big y-intercept and you just want to put a tick mark and then label it, I'm also okay with that. I'm not going to count off there if you don't have 16 tick marks counting down. Just make sure you label what it is. So my graph starts up here. We have to hit our x-intercept, and we said it will go through. So it's going to come down and hit your y-intercept. Have to come back up to hit this point on the x-axis. Again, we said our graph goes through. So I get something like this. Okay, again, if we want to double check those, what do we do? Graph. Alright. Is that one okay? Let's try one or two more. Let's do this one. What is the degree of this thing? I'm going to need that to find my end behavior. We have 5, 6, and 4 here, so the degree is 10. So the end behavior would be what? Up. Okay, second step, the zeros. Is it hard to find this time? No. It's in factored form. What would make x to the 5th equal 0? If it's just a plain x, it's just 0. Because it's a 5th power, my multiplicity is 5. What makes x minus 3 0? Positive 3. X plus 4? Okay, 4 multiplicity is 4. Does everybody know where I'm getting those? Next step, do we bounce or go through? So this one, multiplicity is 5. 5 is odd, so it will go through. 3 just has a multiplicity of 1. 1 is odd, so it goes through. -4, my multiplicity is 4. 4 is even, so the graph will okay. Y-intercept. If I plug in 0 for all my x's, 0 to the 5th is 0. 0 minus 3 is -3. 0 plus 4 is 4 to the 4th. Where do we get there? It's going to be a large number, isn't it? -768. Okay, step 5 is the graph. I know my end behavior was up, up, so both ends should be pointing up. My zeros are where we hit the x-axis. Hold on, that's not -768, is it? That's an easy one. I didn't multiply by my 0.
Yeah.
I ignored that. 0 times anything is 0, isn't it? That's much prettier. You guys are just going to let me go with it? Nobody's going to say anything? Okay, so we hit our x-axis at 0, positive 3, and negative 4. We hit our y-axis at 0, which I already have. Okay, so drawing my graph. I'm starting up here because my end behavior, this end was pointing up. So if we come down, we have to hit our first x-intercept. What happens at negative 4? It bounces. So it's going to bounce back up. Then we have to come hit the 0, and at 0 it goes through. Then come back and hit the 3, and at 3 it goes through. So our graph looks like this. Is that okay? I'm going to do one more and then I'm done. Let's do this. What's the degree of this? 3. So then my end behavior, odds look like a chair, but there's a negative in front, so it will up, down. Good. Step 2, the zeros. Okay, it's not as obvious, but what could I pull out of all of this? An x. Can I go ahead and take out a negative x so that'll be a positive? Is that okay? Then I'm left with 2x squared minus, or plus x minus 1. If I take out a negative, changes all my signs. Then what do we need to do? Let's go ahead and just do box method. We're going to have to do it in a second anyway. So what would multiply to negative 2 and add to positive 1? Positive 2 and negative 1, because I want a positive in the middle. Since I pulled out a negative, it changed all my signs. Then we have 2x minus 1, x plus 1. Okay. So then, my zeros, if I set each of those to 0, what makes negative x equal 0? What makes 2x minus 1 equal 0? And x plus 1? Alright, so those are my zeros. Step 3, is my graph going to bounce or go through? Should go through all of them because they all have a multiplicity of 1. Step 4, the y-intercept. If you plug in a 0 for all of your x's, what do we get out? 0. So then we can draw a graph. In behavior up, down, so it should start up here and end down here. Hit the x-axis at 0, 1/2, negative 1, y-axis at 0, which I've already got. My graph was starting up high, so it's going to start here. Come down, hit the first one. We said it's going to go through all of them, so I cross through, come back and hit my 0. Cross through, come back and hit my 1/2. Go through, and it ends pointing down, like we said. Any questions? Okay, I am stopping there. For homework, there is a handout posted on Classroom, but we are not going to do all of them. I want to do okay. So on your handout, it's 4.3 day 2. I want you to do 1 through 3, 7, and 8. So you have 5 problems. You've got some time right now to get started on